All right, so we're going to talk about hydrogen fuel cells, and these are kind of this is something fairly new. These are kind of new things. The idea, the really nice thing about them is there's no pollution. When you take hydrogen and add oxygen, you get water, and there's no pollution there. So it's a pretty clean fuel that we can do. If we look at the trends in the use of fuel and the percentages of hydrogen, it doesn't have like the numbers up here, but you can kind of see, obviously if you have pure hydrogen, that's 100%. No, that's, hang on. Yeah, I suppose. All right, so here's your PowerPoint handout. All right, so you can see that wood has some hydrogen in it. Every living thing has hydrogen in it. So there's some hydrogen in that. There's a little bit more in coal, oil. Natural gas has a lot. And then, of course, hydrogen is mostly hydrogen. Would make sense, right? All right, so here's kind of some ideas of some engines that we've had. A long time ago, we had the steam engine, which, was pretty revolutionary at the time, pretty amazing. Now, today we use the internal combustion engine, and perhaps down the road we'll have cars powered with fuel cells, hydrogen fuel cells. And so we just plug in, go to the gas station, get some water, and take off, or something like that. All right, here's the idea of what a fuel cell does. First of all, if you take electricity and run it through water, you can actually separate the particles into hydrogen and oxygen. So that's what they've done in this diagram, is we've actually separated them into hydrogen and oxygen. We put a battery on it, and we did that. And I've done that in chemistry several times. And then if you go and put like an ammeter back on it, you can actually go the other way. And that hydrogen and oxygen will recombine and form water, and you get some electricity from that. And that was first done way back in 1839. So this idea hasn't been, it's not something brand new. It's just the use of it is newer than any of those. Here's, and I can't tell you from this picture at all what any of this stuff is, but apparently he was doing something with hydrogen fuel in 1955. So there's a pretty picture of that. And
Mrs. Campbell, could you go to room 401, please? Mrs. Campbell to room 401.
Here's an actual hydrogen fuel cell that was in the space shuttle. So that is a very good question. I have no idea. I really don't know. I don't know if it's... Yeah, my guess would be, assuming that the buttons are like finger size, it would probably be maybe a foot or two tall by, 3 or 4 foot wide. I don't know. That's a good point. They didn't put anything for a frame of reference here, so we can kind of see what the size is. But I would guess it's not too big. Bigger than a bread box maybe, but not too big. And, there is some application for fuel cells in cars. They are working on this right now. That's one of the things that, car manufacturers are testing out, fuel cells and so on. There's also power plants that can create power from fuel cells. And I don't know where this is. It doesn't really tell me Ballard Power Systems, but I don't know where that's at. Or you could even maybe get one for your house. Now, that'd be all right. You just take some water, put it in there, and you get your power. Yeah. And here's a portable one. Okay. They don't tell me a whole lot about this. I tried to find information. There's just pictures. There's just basic stuff. I think the thing is, this is new enough that there just isn't a lot of, ongoing information about this. But here's just a portable one. And it says it's made with metal hydride storage. In other words, what's in there is a compound that is formed from some kind of a metal like calcium or sodium or something and hydrogen. And then you take that metal and you break it up and you get the hydrogen and the metal separated, and you use that hydrogen for your fuel. So here are the different types of fuel cells that are out there. Once again, there is not much elaboration on this in any of my stuff that I have. There's alkaline, phosphoric acid, molten carbonate, that sounds really hot, solid oxide, direct methanol, and polymer electrolyte membrane. Okay. Yeah. Now, here's what happens in a fuel cell. First of all, you take hydrogen, and what we do is we break it down. We take the hydrogen gas, we break it into hydrogen ions. When that happens, electrons are released. Well, electrons are what we need. That's what we have for electricity. At the other end, at the cathode's the positive end, the anode is the negative end. At the other end, you take oxygen with those electrons plus this hydrogen, and you form water. This is known as reduction. This side is oxidation, this side is reduction. And here's the overall reaction. And of course, you know, it seems kind of weird to see a half, but they're just trying to make it so that these are whole numbers for the hydrogen. Normally that equation is 2, 1, 2, you know, for your coefficients in there. And when you do this, you get about 285 kilojoules of energy for every mole. And for those of you who aren't familiar with that, a mole is a counting term in chemistry for every mole of water that you have or every mole of hydrogen that you have. So basically what we're saying is for every 6.02 times 10 to the 23rd hydrogen molecules, we're going to get that much. Okay, it's a big number. Okay, or how about this? For every about 2 grams of hydrogen, that's what we're going to get. All right, so here's a simple fuel cell, and if you take a look at it, what you see is on one end, the hydrogen comes in, and the electrons are going to travel through the wire, through the load, and over to this side. So remember what we've done is we've separated out the hydrogen ions, we've separated out the electrons. They want to get back together. Well, what we do is we create a path for the electrons to go, and we get some energy out of that, and a path for the hydrogen to go, and it meets up with oxygen, and at this point we're going to now form our water. So the electrons go through here, come out on this side, the hydrogens go through a membrane, come out on this side, on the same side, meet up with some oxygen, and we form water. And that's the idea of a fuel cell. Here's a little closer look at what's going on. One of the reasons that these fuel cells are fairly expensive is they require a catalyst, and that catalyst is platinum. And platinum is not cheap. Yeah. So you have to have this platinum catalyst when we do that. In fact, our solar cell or our hydrogen cells have this catalyst in it, and we, you know, that's one reason why those cells are relatively expensive. But what you need in order to break that hydrogen up, it doesn't just happen on its own. But when this hydrogen meets these little platinum catalyst things, it does tend to cause that to happen. So you need that catalyst here to break it up. And you also use the catalyst to put it back together into water. So we need that catalyst in there to make that reaction take place. Otherwise, that reaction is way, way too slow, and there's not near enough of it without the catalyst. Yeah, here's a pretty picture of the things. You know, I assume what they're talking about here is we've got this long chain, this poly. Anytime you see the word poly in a compound, it means it creates these huge, huge molecules. So we take these things and we link them together. So you get things like polyethylene and polyvinyl chloride and all of those kind of things, which are really, really long, huge molecules. Well, this particular one apparently forms long chains, which actually trap these water molecules in there. And that's what the membrane is. And somehow, you know, I wish it explained a little bit more, but it doesn't really tell you a whole lot right here about what's going on. So, yeah. The thermodynamics of it, you know, we talked about that there was, well, of course, in the last slide it was what, 285.8 kilojoules, and now we're talking about 285,000 joules. And then they go in and they throw in this idea of Gibbs free energy, and let's just not worry about it. But let's just basically say that this is energy that I guess the long and short of this is at the end what we get out of it is 1.23 volts. That's how much energy we get out of our fuel cells. These cells that we're going to use. Okay. And it does make a difference at what temperature you run these at. So notice that if I'm at 25 degrees, I get 1.23 volts. If I'm up to 80 degrees, I only get 1.18 volts. So the temperature does make a difference when it comes to running fuel cells. Okay. One of the problems is as you run these fuel cells, you actually lose voltage as you start to lose concentration of the hydrogen and so on. And that's, I think, what they're trying to show you here. Once again, a slideshow without very little, with a lot of really fancy stuff and very little background knowledge for any of us. So I can't even tell you a lot about it without looking some of this stuff up, which I don't know. All right, this is what they're trying to show you here is different ways that you could store a kilogram of hydrogen. So if you had hydrogen as a gas and you compressed it, it would probably take up about 56 liters to get a kilogram of hydrogen gas. On the other hand, if you had it as liquid hydrogen, it would only take 14 liters. Now, of course, there's a problem with that. You got to be a whole lot colder to have liquid hydrogen. It has to be extremely cold. And then the last one is if it's in a compound like what we talked about before, a metal hydride, then only 9.9 kilogram or liters would require to do that. So that's probably one of the more efficient ways of storing hydrogen compared to some of the other ones. All right, so here's hydrogen. We get energy forever. You've got the fuel tank into a reformer, hydrogen bottles. Yes, that's really nice. So we can, I guess what they're trying to show you here is we're taking some kind of fuel and producing hydrogen. We can also take solar panels, run them through and get hydrogen. Or even nowadays they're trying to come up with ways to create hydrogen from algae. So all of these are possible ways that we could get hydrogen gas, which we can then use as fuel. So we can take any of those ideas. We can take solar cells or wind or any of those, turn them in, run them through the electrolyzer and get hydrogen and use that with oxygen to create our fuel cell. We get leftover water and we get electricity. So as long as the sun shines, the wind blows, the river flows, we can have clean, safe, and sustainable electrical power. So the idea of hydrogen is the hydrogen becomes like a battery, I guess is what we're trying to say here. You still have to charge it up. You've got to find a way to create it, the solar cell, the wind, or water. But then once you have that, you've got this clean energy source that you can use. So some benefits: it's clean, it's quiet, safe, efficient, sustainable, and modular. And we have to have our responsibility to our fragile planet. All right, there you go.